Hello everyone. In this session we're going to discuss the reasons why your Horizontal Pod Autoscaler or HPA might not be scaling your pods, even if everything looks correctly configured here. So let's begin. Throughout this demo I will use two of the following manifests. The first one is a deployment starting on the Ubuntu pod, on which I have previously installed the stress utility to trigger CPU and memory consumption. And the second one is the Horizontal Pod Autoscaler itself, in which we'll define the scaling threshold of 50% CPU utilization. So I've already applied those, and let's see how they behave. So we'll describe here the pod and the HPA. And here we see that the Horizontal Pod Autoscaler fails to retrieve the CPU usage, the current CPU usage. So here we have the desired target CPU usage that we've defined to be 50%, but we don't have the current one. So this is the first reason why HPA won't scale. It's a pretty obvious one, but still worth mentioning it. It's the metric server. You must have the metric server installed on the HPA on your cluster. Indeed, Kubernetes scales HPA based on resource usage, and without a metric server, it will have no way to measure this usage. And one way to check if the metric server is installed is by running kubectl top pods. And if you get an error here, as we just did, you need to install the metric server using the following command. So now we'll install the metric server, and notice that even when the metric server will be installed, it will take some time for the HPA to retrieve the CPU or any metric. So we still see unknown. This is okay, it can take up to 2 minutes, but while it's taking the metric, it's retrieving the metric, I will try to stress the pod by running the following command. So the following command will execute the stress utility on the pod, and it will create a process that will use one CPU, one core of CPU. Now, if you remember, we defined a 500 millicore limit for this pod, and sorry, that's not this, and therefore it will never reach one core of CPU, but it will instead be throttled to use the 500 millicore limit that was defined. So now let's check the HPA. And here we see that it successfully retrieved the metric. Here the CPU should go up to 500%. And yeah, we got to 500%. I'll explain why we have here 500%. So the request CPU was 100 millicore, but the current usage is 500 millicore. So we tried to use one core, but we are limited to 500. So the pod is currently using 500 millicore. And 500 millicore is 500% times 100 millicore. It's like 5 times the request. Thus the 500% that we've seen. But since now the pod, the HPA, is scaling, we can see here that the replica has changed. So we have 4 replicas. Even now we have 5 replicas. So now this amount is reduced to 100% because the total usage of CPU is 100% of the total number of requests defined among those 5 replicas. So that was the first pitfall. For the second one, we will take a look at another deployment. So we have this deployment, and we have an HPA defined similarly to the previous one. And again, I also have applied that. So we will check the behavior. And again, here we see a failure. We see unknown in the metric, the CPU metric. So this time we have the metric server, so we can even check. So here we have the actual usage of the pod, but still the HPA doesn't get the metric. So if we take a better look at the deployment, we will see that this container is missing the request the request for the CPU that we're targeting with the HPA. So when here we target a metric, it can be CPU, it can be memory, it can be anything, we must define that metric in the request of the containers of the deployment. Here we have one container, but if we had multiple containers, this requested resource has to be defined in all the containers. Because here we're saying I want my pod to use at maximum 50% of the requested amount of CPU or memory that I've defined. So here, if we don't have any request set, then it will just don't know 50% of what. So now we will add the following resource and request. I would say okay, like that. So I will put 100 millicore CPU. So I'll save that, and I will apply this deployment. And as before, the HPA isn't changed, but the deployment has been configured. So now if we describe the pod, we should see one dying and another one coming to life. Yes, and as before, here the HPA might take some time to retrieve the metric. This is totally normal, so wait a minute or two until after you update your deployment, and you should see the metric retrieved. So we'll just run a few commands and until we actually prove that we solved the issue. Okay, this one's taking a long time to actually retrieve the CPU. Okay, and now it has retrieved. So if you see 0% here, this is a success. It means that it has actually retrieved that your pod is using 0% of its requested CPU. So now let me show you another, the last pitfall I will talk about. So it will look something that looks like a bug, but actually isn't. So let's take a look at this deployment. So this deployment has multiple containers. So this pod has two containers, a master and a worker pod, and we are defining an HPA on the memory. So we're saying that we want each pod to have a maximum 80% utilization of the memory. And let's check that we define the requested memory. So okay, so here the memory request is 250 megabytes, and for the worker container the memory request is 500 megabytes. So let's now max out the master container. So we'll run the following command as we did before, but this time the stress will be on the memory. So I'm going to describe the pod to get the pod name. Okay, and I'm going to run this command. This command is going to create a process that will use 230 megabytes of memory. Now, if we take a look at the deployment again, we'll see that 230 megabytes is actually 80% of the master container. So the master container will almost be using all its memory. So we should expect the HPA to scale in order to create another pod to relieve this this master container. So I'm gonna do top pods, and we see that the memory is increasing, but we actually do not see any replica from the HPA. The master container is at its limit now, but still no scaling happens. So did I make a mistake? There is no mistake here. So here's the explanation. HPA doesn't look at each container individually. it calculates total pod usage over total memory requests. So here, in our case, let's open the deployment one last time. The master is 250 megabyte and the worker is 500 megabytes. So the total request is 750 megabytes. And 80% of 750 is 600 megabyte threshold. So unless the pod itself in its totality didn't get to 600 megabyte memory usage, it will not scale. So that can be confusing because you have one container that is basically full and cannot breathe anymore, but still your HPA doesn't scale it because it's the overall memory or just request usage. So you have to pass the overall memory that we've defined. If you want do HPA to monitor just one container, it's possible, and we'll see this HPA container. So we take a look at this definition. So here, what we're saying is that we want this HPA to check the utilization, the memory utilization of the container named master. So if this container exceeds 60% of 250 megabyte, so roughly 150 megabyte, we should see this time the HPA scaling the pod, because here we are targeting the specific container. So we're going to apply this HPA container. And now we're going to rerun the stress command on the pod, still on the master container. So if we take a look at if we do a top pods, we'll see the memory increasing. And if we take a look at the HPA, well, here we'll see that we just passed the average utilization that we defined. We defined 60%, and here we are at 62%. So here we should see that the HPA, scaling our pods. Okay, it doesn't scale. Even if we passed by 2% the request, we still didn't see any replica. So I will try to run this command again. This time I will try to use maybe I'll change this one by 9. Hopefully this will make this will load more memory, and we will pass the threshold. Okay, and here we see clearly that we're passing by a lot the scaling threshold. So now we should see the replica increasing. And there we go. We got 2 replicas. So that's all for this video. I will stop here, and I hope you enjoyed.